2 minutes. Let us see if anyone is joining. Okay, Kumar.
Okay, sir, sure.
Yeah, okay. Fine. So no one is joining, so we'll start. We'll start about Terraform. So what is this Terraform? You're able to hear me, right, Kumar?
Yes, I can able to hear you.
Okay. So it's an infrastructure as a code. What is in the infrastructure? What we call it as an infrastructure?
Most of the things will be taken care by Terraform itself.
That is fine. That is a tool. This Terraform is a tool. It's mainly for infrastructure creation. Infrastructure as a code. That means all these days we might have created a EC2, S3 bucket, and all those things. We created by ourselves. Correct, na?
Yes,
So now instead of that, we go develop or create the infrastructure. That is the resources we create by code. Okay, that's called
okay,
infrastructure as a code. So I think we have done Docker, Jenkins, and Kubernetes. Correct now. So what is
yes.
Kubernetes actually? What tool it is? Kubernetes is what tool? Kubernetes is a
Deployment scaling,
no no.
content orchestration tool.
Ah, Kubernetes is an orchestration tool. Docker is a containerization tool. Jenkins is what?
Deployment tool.
Deployment tool. Huh? Jenkins is an automation and integration tool.
CI/CD.
Okay. Uh, CI/CD pipeline. Correct. Now
Yes,
Terraform is what? Infrastructure as code. You're saying in the chat box, right?
yes, yes,
Okay. So we'll explore this one. What is this Terraform? So Terraform was last invented by Hassie Corporation, which they released in 2014 as an infrastructure as a code solution. Why we need this infrastructure as a solution? Because we have to go manually and type everything. I mean, we have to go manually and create everything, right? So
yes,
instead of that, we want to deploy all the resources in one shot. All the resources in one shot. Like yesterday, we have done EKS. Yes,
yes.
EKS, we written only one code. That code has developed everything. Do you see that? Did you see that it was creating the? We created a demo cluster, correct? Na? Inside that
Yes.
cluster, what are all the tools, things necessary? It has to get installed. It did by itself. Okay.
Okay,
Now, what is the difference actually? What is the difference? For example, we have launched EC2, correct? Huh? We
correct.
have launched EC2. Now, what are the steps involved in EC2?
Create an instance,
Hmm.
a security
Then,
group for that instance.
ah, then, then we have to select the network. We have to
Yes,
select the public subnet, auto public enable, key pair. We have to create it. Select to Ubuntu, correct, and
correct,
value everything, correct. Now there are lot of steps are there to do create a resource, correct. So
correct.
now those who are very new, will they be able to, if until and unless we also, if we are not doing it multiple times, we don't remember the exact steps, right?
Right,
So instead of that, we'll go and remember all these things. Why don't we have a code option? Why don't we have a code option? See, main thing is why we want to have DevOps. We want to automate things, correct? Na? So at that
correct.
time, we cannot go and do manually things. So to avoid that, we write a small code. which is very simple code, not like project code and all. Just a 2 line, 3 line code or 1 line code, which we can able to. With that code, we can able to create multiple things at the same time, multiple resources at the same time. Okay, that's what the main thing why they want Terraform, as Terraform mainly for infrastructure as a code solution. And like the other third party services, what is the main advantage of Terraform? What is the advantage of these third party tools actually? Like Terraform, Kubernetes, Docker, what is the main plus point?
Deployment in a cloud support.
Deployment, cloud support is fine. One more in that main reason is also there. What is that? Is it going to support only AWS?
Oh, no, no, it will support Azure, other.
Yes. So that's what it will support, multi-cloud. It will support multi-cloud. So expanded to support AWS, Azure, GCP, and on-premise environments also. So Terraform can able to support for multiple things as well. Next, it will follow a declarative approach. It will follow a declarative approach. So I think we might have learned in Jenkins. Do you remember scriptive approach?
Yes,
Yes, two types of approaches were there. Na? Scripting, another one is the other one. So same thing here. We have a declarative approach where the file names. I think in Jenkins, what is the main file name?
PM,
Jenkins file.
PM file.
No, no, no. Jenkins file.
Yes,
Same thing for Docker. What is the main file?
PEM file.
Docker file. Docker file. The file name is Docker file. Jenkins file. Right. Same thing here. We have Terraform. The extension will be .tf. Extension would be .tf. It introduces simple .tf files to describe the infrastructure needs. Okay. Now, why you choose Terraform? Why you choose Terraform? It's an infrastructure as a code, as we already mentioned. It will have a version control also. What is my version? What is a versioning control tool, which we have learned? Hmm?
GitHub.
Yes. So Git is your version control tool. Now, Terraform is also saying that it will take care of versions. Versions means what it is going to do. Okay, in Git itself, if you're not doing any change and you give a commit, what will happen?
It will ask which commit description.
No, you're not done any changes, okay, in your file.
Okay.
Already version one is there, and again you're giving second commit, but you didn't change even a single word. Now, what it will show? Will it get updated again?
No.
No, right?
Yes.
Yes. So same thing here also. Terraform first time it will keep a version. If there is any update alone is there, that alone will get updated, not the full file. Okay, and also if it is already the file which you have already created has no changes, then it will not change anything also. Because as for the thing, we are not change anything, so it's not going to change anything. Next, share. We can able to share the resource. We can reuse the infrastructure definition as code files, because here we are creating this infrastructure definitions. Infrastructure definitions means, for example, now EC2 is there. Now EC2, you only just now told that you have multiple steps, correct? Na? You
Correct.
told multiple steps: EC2, key pair, Ubuntu selection, security group, all these things. Now all these things we are going to type it in 4 or 5 lines, just a word equal to this one, equal to that, that one equal to this. So now when you type like this, what will happen? I can able to reuse this code for some other projects also. Am I right?
Yes.
Because the creation of EC2 is same, creation of VPC is also same, creation of S3 bucket is also same. Now I don't want to write the code again and again. If I have used this same code, this code in some other project, I can just copy and paste it. Okay,
Okay.
so that's what definition as code files, and we can reuse the infrastructure definitions as it is. Next, again, it will cloud Terraform will support cloud, multi-cloud support. It will support all the three, that is AWS, GCP, Azure, and even now Kubernetes. As Kubernetes also becoming a big one, as I told you, it will support Kubernetes as well. Next, automation and repeatability. So set up identical infrastructure repeatedly without manual effort. Without manual effort. Set up identical infrastructure. What is in by identical infrastructure?
Automation.
Identical, no. Identical means same. Identical means same. No? Identical twins are now we are saying na.
Yes, yes.
What is in identical means? Same. So same definitions we can able to use repeatedly without manual effort. We can able to just call that file or copy that file or reuse the name that file. We can reuse it. So automation become repeated. Automation and repeatability is there. Next, safe execution. So we can able to preview the changes before applying them to the infrastructure. That means like your Docker, how many commands we used? Do you remember? Kubernetes, we used only one command, that is EKS, then name a cluster, a region, and what you want to create. Correct?
Correct.
Now, same thing. Docker, we created only two commands. One is build command, Docker build image, and another one is
Run,
Docker
test.
run. Run test is we manually go and test checked it. It's deployed or not. Correct? Now,
Correct.
safe execution, preview changes before applying them to the infrastructure. So now here, first we write the code and we can put Terraform, one more code called plan. Once you put the plan, you will be able to see before you deploy this, before you run this infrastructure, before the infrastructure is going to get created, you will come to know whether it will create properly or not, and what will be the output, whether everything is ready properly or not. That we'll be able to see. Okay, that's called safe execution because it can able to preview the changes before applying them to your infrastructure. Next, understanding the differences. There are two types of scripts are there in the Terraform. One is declarative Terraform and imperative scripts. So declarative is we describe the desired final state for your infrastructure, what you want the final state. And imperative is we provide the step-by-step instructions to achieve a state. So it's like your procedural language. Another one is what are the two types of languages? What are the types of languages?
Programming languages or
Mhm. Procedural language and object-oriented language, correct? Na? Or
yes.
procedural language. So object-oriented is like your C++, Java, and all those things. Object which revolves around object. Procedural language is step-by-step instructions. So this imperative is provide step-by-step instructions to achieve a state. So here we'll be having line-by-line control. I think that's what you will know. This what's it? Compiler and interpreter. What is interpreter and compiler? Do you know interpreter?
They will execute
It'll execute
our output, run and execute our output.
which one?
Compiler.
Okay, then interpreter is what it will do. So this imperative is interpreter. That is what step by step. Interpreter is line by line interpret and check whether the code is correct or not. You will check the result immediately. Compiler is at a whole. At a whole, it will if you're writing three lines of code, all the three lines of code will execute at once. That is called compiler. Interpreter is line by line only it will execute. I think yesterday we have done when we do that, sometimes we put interpreted lines line by line we execute. Sometimes we did it in one form, but compiler when you do, it'll read everything in and hold one shot. Yesterday we write the command na
Yes.
in the AKS.
Yes.
Yes, same thing here. Terraform follow the declarative method as we just now we mentioned. Na, it'll go with the declarative approach. First, less fine grained control. Because of this less declarative approach, we have less fine grained control. Less fine grained control means what? You will not have the full control. You will have some partial control only. But here it is line by line, so you'll have a full control. That's what fine grained control. That's called fine grained control. So full control over each command and execution order. You'll have full control over each command and the execution order as well. Situational use. So mainly we'll use this for long-term infrastructure management as it's a fully the plan and order everything will be same. So our job is only to take and use it. Here it is mainly for a quick fixes, temporary setups or scripts. Best for quick fixes. Best for quick fixes, temporary setups or scripts. Because it's line by line it's going to interpret, so we can able to change it. Next, state management. The state management means what? You want to put some data or a value that wants to get changed dynamically frequently. So for that state management we need. Now Terraform automatically stores and compares the current state of infrastructure using a state file, enabling efficiency. I think yesterday we have done this cloud front. Na? In that you're able to see import React. We have put a file called app.jsx.
Yes.
Yes, in that first line, you see, you're able to see use state. If you open, you'll be able to see use state.
Yes. Yes.
Yes, and below in the commands, we might have returned a constant one value and comma set value.
Yes.
Okay, maybe you just share your screen. Is it there?
Yes. I'm seeing that one only. I'm sharing my screen.
Share your screen. Or
The
you want to make
host
it
isn't allowed.
co-host? Okay.
Please give me permission.
Yes, yes, done.
I'm sharing my screen.
Yes, yes, fine. So here you see the constant is playing is there, na?
Yes.
Fifth line is playing. Now is playing is the current state. Okay, is playing is the current state, and set is playing is update state. Okay, so current state what we are mentioning, current state we are mentioning use state is false. That is default it is false. If anything updated it will become true. Same thing current time and set current time. So current time it is keeping us to 0. Set current time is the updated value should get replaced here. So this is a state value. If you scroll down you'll be able to see, yes, you see is playing is true, else we do not current pass. If playing is true you want to continue the video, if not it is passed. Okay, so wherever you go, wherever technology, whatever technology is especially in computer science and programming, you will come back to this state method, state management. Same thing only here also in Terraform. Yeah, you can stop sharing. I will just share. Same thing for Same thing for here also in Terraform. You see, Terraform automatically stores and compares the current state and update state. That is, current state means what? The initial value, whatever you mentioned in the first version, and it will go and store it in the state file. If you are updating anything, first it will go and come and check the state file. First it will go and come and the check in the state file whether the data which you entered is a new one or not. Okay.
Okay.
Next, state management. You must track changes and progress manually because here it is a step by step in sections. So you must track changes progress manually. There is no internal record of current infrastructure state. So it will not have any record copy because it's going line by line and we are frequently changing the lines. So it will not keep a record. We only have to manually track the progress. Next, what are the limitations here in this declarative approach and the imperative approach? So, declarative, you see, Terraform decides the execution order internally, which may not always align with your expectation. So, okay, if you want to launch EC2, what should be launched first? Yeah, Kumar, so if you want to launch an instance, okay, you want to launch a server,
Okay.
what you have to do first in the
Go to
AWS? Mm,
EC2 instance
mm.
and create an instance.
Now you can directly go. Now you deleted everything, right? Yesterday.
Yes, yes.
If you able to go and log in and create an easy to instance, will it work? First of all, will you able to create it first?
EC2 instance, right?
Easy to instance.
Yes, it will work.
No. If you want to launch easy to instance, where will you launch? You want to launch the VPC. I mean, you want to launch the EC2 in where actually? Inside a subnet, na?
Yes, yes.
If subnet you want to know, no, you want me, then what you need to create first? You need to create VPC first.
Okay.
Yes sir, no, all these days we are doing that only, right? First VPC has to create it. Yesterday EKS automatically created the VPC. That's what you deleted also, na?
Yes,
EKS
correct.
VPC. Yes, first VPC has to create it, then only EC2 has to create it. So this order, that's what Terraform itself will decide the execution order internally, which may not always align with your expectations. So it will do by itself because it knows what has to done first, what has to do next. Right? Since you don't define individual steps, tracking down what went wrong can be challenging. Yes, because we have not given the steps fully properly means it will be tough for us to calculate what is happening. In sense, it will be challenging what went wrong. How will you able to find it? Because Terraform itself will decide the internal order. You might be expecting, okay, you might be expecting that you want to launch a server. You might be expecting that we can able to launch only in EC2. But VPC itself not configured properly, it will not work.
Okay.
Next one, mismanaging the state file can cause issues like resource duplication or deletion. Yes. So when we create Terraform, automatically the state file will get created. Okay. Now, in case if the state file you are deleting or you are cut and pasting it some other location, then what will happen? The resource will create automatically again. For example, you put the same code and run it. You got the values, everything, and it's already stored in the state file. Now, if the state file is deleted, either you deleted or is it outside the folder or it is not in the correct place, what will happen? As we just a few minutes before I told you, it is going to compare your previous version. It is going to compare your previous version to the updated one. So, if the previous version copy itself not there, what will happen? What will happen? Let us say you are pushing this yesterday's file is there, no? What is that? That video file
Yes,
or the
video file.
BMI calculator. You have moved to. We moved the BMI calculator to GitHub, correct? Na?
Correct.
If we are moving this GitHub again, what will happen? If I'm not doing any changes, nothing will happen. Correct? Na?
Yes, yes. Correct.
That's what I told you. Now, in case if you go to your GitHub repository and click that repository and delete it manually. What? Delete it manually,
Manually.
and now you're pushing it from your VS Code. What will happen to the same repository? What will happen? You getting my question, Kumar?
Once, can you please repeat it once?
See, you are already having a BMI calculator in your folder. Okay, you created a repository called BMI calculator. And how do you push this BMI calculator data into it? Through command line. Correct now?
Yes.
Through VS Code, you put the GitHub commands and pushed it to the folder repository. Now you push it through command line, but you are going manually and deleting whatever files inside. Okay.
Okay.
Now again you are pushing this file from the VS Code. Now what
It
will
will
happen?
it will throw error.
It will throw error. Okay, wait. Now, if the file is already there, let us say you didn't delete it anything, okay, and you
Okay.
are not changing any updated data here also, okay. You didn't update anything, but you are again pushing it to GitHub. Now, what is the command it will show here in that this one terminal?
It will show by I mean uh, successfully conciled. That one it will show in red color. Webpack compiled successfully. Instead of that, it will throw error.
Uh, no, actually, what it will do, if you see, usually when you push any data to GitHub, finally, it will show the data are pushed. But how many number of data it will show? 40 files are pushed. It will show 40 files are pushed or changes. Changes made to 40 files. Like that it will show. Okay. Now the file is already there, and again you are pushing without doing any change means what will happen? Means it will run in front of you, it will run. But nothing get changed, so it will put zero changes. Correct now?
Correct.
Zero changes it will show. That means nothing has been changed. Now, same thing only here. If you are removing this, not removing the state file, and you didn't update anything, means everything is already there in the state file. So you don't want to do anything, repeat it again. Even if you repeat it, also it will not reflect. The state file is already recorded that this command, so everything has been done. It's working fine. Now, no changes in your new command which you entered. Now there is no change. It will not do any state any changes. It will just be there as it is. But only thing is you should not change the location of the state file, because state file Terraform will look for the state file outside.
Okay.
Okay. So that's what the state file is. See, it like a resource duplication. Mismanaging the state file can issue like resource duplication or deletion. Mismanaging means you are removing the state file from your order and keeping it. For example, I think you opened your VS Code, na? Open your VS Code.
Yes. Shall I share my screen? Okay.
Yes, yes. See here, this package.json is there, na? Left side files. Now click that SRC. Click that SRC. You see, wait. What are the packages? What are the files outside actually? JSON dot package dot JSON, package log dot JSON. Correct now.
Yes.
These are the two files outside. Correct. Now, if you put these two files inside any other folder, if you
Okay.
cut and paste this package.json in the node modules, what will happen?
No idea. Never tried.
Okay. Nothing. It will not work. Your file will not work because this package.json only recording everything. That is what version everything it is giving a main thing. If you replace this location of the package.json, your entire file will not work. Okay. Now, what is happening actually? If you change the location of the file, your program is gone. Program is gone and it does not work because they have automatically said that these files will be there in this location, in this place, below SRC only as a separate file. Like that, it is mentioned. Okay, so we should not change the rule of the or the order.
Okay.
Okay. Now, same thing only. So instead of this package.json, just imagine there is a state file. Okay, state.tf file. TF means what? Terraform. So state.t file is that I should not, that means we should not replace it with any other location. Okay, now you can stop. I will come. Next one, here in the limitations. As infrastructure grows, scripts become long, complex, and hard to maintain. As infrastructure grows, scripts become long, complex, and harder to maintain because it's line by line interruption. So it will become more complex if you go one by one, one by one by one. Next one, you have to manually track what has been done or changed. So we have to manually track. We cannot be able to track automatically by Terraform like that. Declarative approach. Running the same script in different environments may yield different results unless carefully scripted. So same script we should run in different environments so that we can able to get more results. We should not run the same file again and again in the same resource. That's what this one. Next, Terraform primarily uses a declarative approach with HASI Corporation. That is, HASI Corporation is HCL, HASI Corporation Configuration Language. HCL is short form we call, allowing it to automate provisioning and support multicolor environments effectively. Okay, so now it will help you to allow and provision multi-cloud environment effectively. So as we mentioned, Hashi Corporation only was started this Terraform in 2014. Now, what are the key takeaways from this slide? So the history by Hashi Corporation in 2014 to simplify infrastructure management across multiple platforms. And what are the benefits? We can able to see it will support multi-cloud, support automation, reusability, and safe infrastructure provisioning with preview capabilities as well. Next approach, it uses an declarative style focusing on the desired outcome rather than detailed implementation steps. Rather than the detailed implementation steps, we can able to go for a declarative approach. These are the benefits that we learned here in this slide. Let me go for the next one. Now, Terraform concept. Okay, I think you are writing anything.
No, not writing anything. I'll refer this PDF you are showing.
Oh, okay, fine. Now, Terraform concepts. Inside Terraform, what are the main essential concepts? There are four main essential concepts of them, like how Jenkins having three stages: build, test, deploy. Same thing we have here also. That is four essential concepts. One is providers, next one resources, next one variables and outputs. Variables and outputs. So, what are the four essential concepts? Providers, resources, variables, and outputs. First, we'll go for providers. What are those providers? Providers means who is providing this cloud support, who is providing this cloud support, and which region they are supporting. So, providers are nothing but they are plugins connecting Terraform to the cloud platforms. Mainly, providers are what? They are the plugins mainly connecting to Terraform to cloud platforms. And why they matters? So they enable resource creation on specific platforms. They can able to create resources on particularly specific platforms. And the main common examples are you can able to see as we mentioned AWS, Azure, GCP, GitHub, and Kubernetes. So same thing only it will support all the regions, all the cloud, multi-cloud. So how we have to write it? First we have to put the word called provider. Who is the provider? Whether it is AWS or Azure or GCP, what is that? Okay, that you have to mention like a function. I think you know JavaScript function, correct? No?
Yes.
Yes, same thing here. You see, provider AWS and open the curly braces and select the region is equal to which region. So AP South one means one. Which region? We are using Southeast one. South is which one? South is Mumbai. Okay. So they are representing here the Mumbai region. We in our programs we represent Southeast one. So one is providers. Second one resources. What resources we are going to actually build? So resources building blocks. So definition. Components you create and manage. So what are the components we are going to create and we are going to manage? It can be servers, database, or networks. So first we are going to define which resource we are going to create. Previously we mentioned the provider, that is cloud. In the AWS cloud, we in this region we are going to do. Now resource means as usual what resources we are going to use, whether EC2 or S3 bucket or VPC, what resource we are going to use. So here you can able to see importance is resource is equal to actual infrastructure. What actual infrastructure we are going to do, that we have to mention here. So it will define with the resource blocked in resources blocks in configuration files. So here you can able to see now resources is equal to actual infrastructure. So here you can able to see resource AWS instance my EC2. This my EC2 is what actually? Can you guess it?
Class. Class
Cl-
name.
class name. No, it's
I
a
mean,
server. The
yes,
server name.
yes, yes.
Exactly. So server name. Next AMI. Why we need AMI? Main thing in the AWS EC2 the server is what? We have to select the AMI. Correct now.
Amazon image, machine image.
Yes, from that machine image only we are going to take the copy, right? So machine image. We have to mention the ID of that machine image. Next one, instant type. Instance type. Instant type means like T2 micro. T2 micro is what? It's one of the
Instance type.
instant type. So instant type, but now it is T3 micro, correct? Na? Yesterday
Yes.
we were doing everywhere you'll be able to see 3 micro because it's an upgraded version. Now we are mentioning out of this 270 instant types, we are selecting T2 micro. Okay, you wrote about the resources. Next one. Now variables. Next we come for variables. Where we learned variables actually, I think you know variables means what?
It will store values,
Yes, store values for what? Where it will store?
memory.
Huh? Where you store?
It has some memory, right? I mean, some
You know the definition of variable?
Yes, it will store the values in like if we initialize something to input, it will show values in that input. In that with that input, it allocates some memory.
Yes, so variable is nothing but a container. Variable is nothing but a container to store the values. Container to store the values. Correct? So same thing here. We are going to define the input variables. What are the variables I'm going to use it? We are going to use it in this Terraform. So first one, define the input variables. What are the inputs you are going to receive in your Terraform configuration file to make them reusable, to make them reusable and adaptable. Now, first we define input variables in your Terraform file using the same .tf extension to make them reusable. Reusable means I can create one variable here and I can use it somewhere else also, but I have to mention the proper file name and the path. So use them reusable, adaptable, holding dynamic values. Holding dynamic values. Dynamic values means what? Dynamic means
Runtime we can give values.
yes, frequently it can able to change also. It can able to change also. So dynamic values for environment specific settings like cloud regions or instant types. Next, configuration references. Reference these variables in your Terraform code using the var.syntax, example var.region, to dynamically set deployment details with. So references these variables in your Terraform code using the var.syntax, example var.region, to dynamically set dependable details with resource blocks. So I think you might know x is equal to var x is equal to 10 means you can able to use as the x value 10 inside the program anywhere. Correct now?
Correct.
That is called what? If you are able to access it from anywhere in the program, what is that called? So same thing here we can able to call that variable. First we create a variable file and we can able to call inside that program or we can able to copy paste in some other program, but we have to set the path as well. When we are creating the Terraform, when we are creating the infrastructure, we can able to access that variable throughout that program, throughout that entire code. Okay, that's what configuration reference. That means we can refer that file. Next, enhancement facility. So variables allow the same Terraform configuration to be deployed across different environments. Different environments mean what? Development environment, production environment, like that. Or with varying specification without modifying the correct core code, simply by providing different values at runtime. So as you said, like either you don't want to change the value or you can change the value during runtime. Right? That's called your variables. So here you can able to see how we have defined the variable. Variable name is instant type. By default, what we are giving T2 micro. Default is T2 dot micro. The remaining things are same only. Next one, output. So we talk about four things. Huh? One is what is the first one?
Providers.
Yes. Second one, second one is the main
Where
one.
variables.
No, that is third one. Second one. Think, recollect. Second one is resources, right?
Okay,
Second
resources.
one is resources. Third one is variables. Fourth one is output. Output means what result I want to get. So this result will showcase the crucial data after Terraform apply. We are going to write the command called Terraform apply. After that, it will go to display the output. Next, share data. So exposes value to other configurations. So why should you want to see the output? Why should you want to see the output? Any file or any folder?
Generally, whatever we do, we have to see the output, right?
Yes, but usually that will be in the output. Means see, for example, yesterday's this React thing, you checked it in the browser, correct? Na?
Correct.
But will you know that will it run properly in the command line in the terminal?
Yes,
Yes. When there is error, it shows error, correct?
correct,
In the terminal. But if it output is correct, means it will not show the output, but we can guess because no error is shown. If no error is there, that means the code is correct. That's what we come to a conclusion. Am I right?
correct.
Yes. So, but here what we want to show the display as an output. For example, you are launching the EC2 instance. How will you? We are launching the EC2 instance through Terraform. Now, what I want to display in my output? How will you find that yes, EC2 has been created without logging to your AWS management console, without going and seeing the AWS management console? How will you find?
In command prompt, we can there's a command to the status to see the status. So there we can see, right? Command prompt. I mean Ubuntu
No, no, no.
also.
I'm asking. Command you have given, okay, man. See, this is the code which we are going to type it for EC2. Okay, na?
Okay,
What we are instructing in the Terraform, we are instructing in the Terraform, go and create an EC2 with from the AMI called this one AMI 0C55 and with the instance type is T2 micro. Correct, na?
correct.
Now, if I create a server, what I should get? How will you identify the server is created? By getting the instant ID. What? By getting the
Instant ID.
instant. Correct now. Once you create an instance ID will get created automatically. Next to your name, you will be able to see instance ID. Correct? Column.
Correct.
Same thing in the output. What I want to display? I want to display the instant ID so that I can understand yes, the output came and the code is working properly. That's why we are mentioning it as result. Now, same thing here. We go for output result dashboard. Show crucial data after Terraform apply. Exposes values to other configuration. Then command line results. IP addresses, endpoints, ID resources, resource IDs. Just now I told you, na? Okay, if you
Yes.
are going for VPC, what should be the output?
Virtual private cloud.
Hmm.
So, I mean a virtual machine like
Yesterday also we copied and pasted. Do you remember VPC ID?
yes, yes.
Same thing. See, resource IDs or IP address or VPC ID. If you're launching a server, then you give me the IP address. I can just paste it. Na? That's the same thing only. Now, IP address, endpoints, resource IDs. You are able to see that these
Yes.
things can become an output. So now here you see output instance IP. So what I want to display? I want to display the instance IP value. What I want to display? I want to display AWS instance, my CC2 public ID. I don't want my instance ID. Instead of that, I want to display my public ID. We usually launch EC2 instance and we copy and paste the IP address only, right? Public
Yes,
IP only,
yes.
right? In the public browser. So same thing. I want my public IP address of this instance. Instance name my EC2, which we defined here. My EC2. This instance public IP I want to display in the output. That's what they're saying. Output. You're getting now. Terraform in action. So first one, what we have to do, we have to define what are providers, what are resources, variables, and outputs. We define all the four. Next one, that's the first one. Second one is plan. Preview changes with Terraform. So I told you, one there is one command called preview plan. There is Terraform plan. It will just show you the preview of what are all things we are going to do. No issues. What is your expectation? That will give. Next, apply. Yesterday we used apply na, in Kubernetes apply. Apply we created yesterday. Do you remember
Yes.
kubectl apply hyphen f ingress.yml we put? Na?
I didn't remember like that exactly because I am copy pasting from your chart to my Ubuntu, so didn't pinpoint like that.
Fine, fine. You remember something. That's it. That's what I'm asking. So nothing. So the same thing here. It is the command called Terraform apply. Terraform apply will create the infrastructure with Terraform apply. Next update if modification and update is needed. Modify and reapply as needed. So update means modify and reapply as needed. Next one. Terraform concepts summary. What are the summary? Now, what are the things we discussed in this slide? Providers. What providers will do? Cloud platform connection. Maybe if you want, you can write this one. Providers means what it will going to do. It's going to create the cloud platform. It's going to connect you to the cloud platform. That's what platform connection. Resource. You can able to see what are the infrastructure component which we are going to launch. That is resource. Then variable input for flexibility. Input for flexibility. Then output result information. So output will show the result information, variables will show the input for flexibility, and resources will the infrastructure component. And product cloud component creation. Fine. We have done this one. We'll go for the other one. Okay, we'll go for the next module, that is writing and using models. So here is a comprehensive guide to creating reusable infrastructure components with Terraform modules for DevOps, engineering, and cloud operations, cloud professionals. What is Terraform? Now you can write in your notebook what is Terraform. Terraform module is a reusable group of Terraform configuration files. Terraform configuration files. That means we should have all the four files. What are the four files, main files in Terraform for each module you have to create it. One is your providers.
Resources, variables, output.
Yes, same thing. So similar to functions in a programming, define once, use multiple times. Like your JavaScript functions, define once and use it multiple times. What is the purpose? It encapsulates infrastructure pattern to standardize deployments across environments. Encapsulation means what? I think in the OOPS concept you might have learned encapsulation. So the purpose is encapsulates. Encapsulates means what? You learn to OOPS concepts actually.
Yeah, just uh,
You don't
unable
remember.
to recollect past.
Fine. Encapsulation is the best example for your bag, school bag. Okay, school bag. Is it a one thing actually? School bag is only one, right?
Yes,
But inside that bag, what are things you'll have?
books.
You have a lot of things, correct? Na? Pencil, book, pen, whatever it is, correct? But for
Correct.
outside people, what will be visible? So outside people will see the only one bag, but it is inside. Lot of things are hidden. Same thing only here also. Encapsulate infrastructure patterns. Whatever the infrastructure we are writing, that will not be visible to others. Standardized deployment across the environments we can able to do. See, module A, module B, module A, group B, group B. So same thing we copy and paste in another group as well. Okay, now we'll go for the next one. Why use modules? So what we are calling this modules is nothing like your resources is there, na? That is EC2, VPC, and S3 bucket and all those things. So each of these separately we have to create a folder, and inside that folder we have to create the main files. That is main.tf file we have to create. Okay, so modules is nothing but each resources we call it as modules. Reusability. Why we want to do like this? Mainly reusability. So first we write the infrastructure code once, deploy it everywhere consistently. We can able to deploy it everywhere once we return it. Next one, avoid configuration drift and mistakes by standardizing patterns. Avoid configuration drifts and mistakes by standardizing patterns. Configuration drift means what? Drift means change, something happening suddenly without our involvement or notification, unintentionally. Someone tried to do it, or you yourself have collapsed or did something. So avoid configuration drift and mistakes. Next, maintainability. Maintainability means update infrastructure in one place, changes propagate everywhere. What does it mean by propagate? Propagation means what? I think we use this word again already. I asked you guys. Propagation means what?
Increasing,
Hmm?
increasing.
Spreading across. Okay, spreading across, changes propagate everywhere. So whatever you used, you can able to whatever you created, you can able to spread across your programs. Okay, so propagate everywhere. Next, team collaboration. Provide templates for infrastructure standard across teams. Across teams means which team they are mentioning here? Which team they are representing here?
Or I mean, colleagues.
No, no, no. They are talking about always the development team, testing team, production team. Okay, development team and production team. Let us take. Okay, fine. Now, structure of a module. Structure of a module means every module, every resource, if you are going to launch, every resource should have these main files that are known as main.tf. Main.tf. TF. This main.tf only will cover contain the primary resource definitions and logic. What logic primary resource we are going to mention, everything will be in this file called main.tf. Next one, variables.tf. Just now we saw same thing. It defines input variables. It defines input variables and their constraints. So mainly they will put everything in the variables, like whatever we want to use it, we'll put it in the variable and their own constraints we can put. Next one, output. Just now we discussed output file. So it specifies the values to expose after the deployment, what values you want to display, that you can able to display. Input variables, as we mentioned, like the instance name, instance things which we have created, we can able to use as that. So every Terraform module will be containing main file, variables files, and output files. Okay. Next, terraform.tv vars. That means all variables together we are keeping it in one file, so that later in case anything we want we can able to less. You're making a note? No?
No, no, no. I will not making any notes.
Okay.
After you publish this PDF also, I will refer that one.
Okay, fine. I think I didn't publish the previous one. I will send you. Okay.
Okay.
Structure of a model, this one. Done. How to use structure, how to use models. So first we have to mention specific resource, what resource or source we are going to give it. So give reference local path or a GitHub repository URL. Then configure parameters. Parameters means what? What is in by parameter?
Values. Values.
Values, but how? What values? What kind of
I
values?
mean, parameters means what are the required things.
Hmm. Mm, parameters is the values or the conditions that we can able to set. Right? Provide values for the required input variables. It can be a value which we are passing it. Like yes, in the VS Code just now we saw na, the false value by default. Use state false we shown na. Inside the parenthesis whatever is coming is parameter. Same thing, inside the parenthesis we gave it as false first, then it will become true in the update state. So that false which we have given inside the parenthesis is called your parameters. Okay, next, apply configuration. Run Terraform initiate and Terraform apply as usual. So these are the main two commands, this you have to write and keep it. Terraform initiate, that's the first one. You can write this one and keep it. Okay,
Okay.
Terraform initiate, Terraform apply, two commands, and Terraform plan. These are the commands we are going to use, mainly main commands.
Okay. Done.
Okay, now here you can able to see that mouse is not working. 1 minute. Module my EC2 source module EC2 instance. In that, what AMI we are taking, what instant type we are taking. So my EC2 instance source modules EC2 instance AMI instant type T2 micro. So this is how you need to mention the path. Modules, we create a folder called modules. Inside that we create one more folder called EC2 instance. Inside that we want to take all these AMI and instant type we have to launch. Next steps to create a user module. Steps to create a user module. Now, what are the steps to you create a user module? First one, create module directory. First, we create a module directory called module name. It can be EC2 or whatever it is. Or first, you create a module folder. Make a directory structure for your usable, reusable modules. First, we create a module directory. Then we define the resources. Define the resource means, as I told you, all the files will have main file, variable file. So write main file with parameterized infrastructure resources. Next, declare variables. What variables we want to create? So create variables to define the configuration inputs. Then specify output. Specify output. Create outputs dot tf to expose necessary values. Whatever values you want to expose, that we can able to expose it. And call the module. So reference your modules from root configuration exercise. Root configuration files. So reference your module from root configuration files we can able to put. You can able to see create outputs to expose it necessary values as well. So these are steps to create a module. Now outputs from modules. Next output from modules, you can see define in modules. Create outputs in the modules output.tf file. So every module which you create or the overall module I want to show everything as in one output that I can mention it outputs in the modules output.tf file. Reference from the root. Access using module name and the dot output you can able to access it. Next chain outputs. Pass outputs between modules for complex architecture. Now how we are doing this, you can see output my instance id value module dot my instance id module dot my instance dot instant id. Password between the modules for complex architectures. We'll use a real life example use case. What is a real life use example? First one, compute resource. We go for compute resource. What is a compute resource? EC2 is the compute resource. So we deploy multiple EC2 instances with identical configuration. Identical configuration means same configurations. Like AMI we took, na AMI we took, same EMI. I want to launch in T2 micro or T3 micro. That we can mention. Next, network interface. Create standard VPC across development, staging, and production environments. Since we are going to use the VPC, one VPC only, inside that itself we can able to go with all the stagings, development staging, production stage, and every stage we can able to keep it in one VPC only. Next, database cluster. If you're creating database cluster, then standardized database deployments with consistent security protocols. We can able to do standardize your database deployments with consistent security protocols as well. Next one, storage solution. So we can able to access the access of storage also, that is S3 bucket. So we reuse S3 bucket creation logic across multiple projects. So S3 bucket is we can able to create it using your Terraform, and we can able to use the same file for multiple projects, same folder buckets for multiple projects also. So that is The real life use case. One minute, the mouse is not working.
Okay.
Not working. Scroll here. Next, what is the summary here? What are the things we discussed here? So purpose mainly where which purpose we have what purpose we are going to use it. We do use infrastructure logins across deployments. That is one why we want to create this, why we want to have this Terraform. Next key components. What are the main key components? Main.tf, variable.tf and output.tf. So these three files should be there for each modules. Implementation called by module curly braces block in root configuration. So how we are going to implement. Next, what are the benefits? Reusability, readability, and standardization. So modules transform infrastructure management from repetitive tasks to strategic architecture also. This file is done. Writing in missing modules. Next, deploying and reviewing. Deploying means what?
Deploying means generally we run our
Hmm. We use this deploy command in the Jenkins actually.
yes,
Yes, deploying means what? We are launching something. We are launching our application on top of something, correct? So it has
correct.
to run. So it's comprehensive guide for DevOps engineering to effectively, efficiently deploy and review cloud infrastructure using Terraform modules. These techniques will create maintainable and scalable infrastructure as code. First, deploying infrastructure using modules. So as I told you, modules is nothing but the one resource that you create. So organized modules separate logical components into reusable units. So modules, what it is going to do, because we are going to create a folder called EC2 separately, again S3 bucket separately, right? So modules organize scalable, so easily deploy multiple instances of the same architecture. We can able to deploy it at the same time. Next, standardization, enforce security and compliance requirements consistently. We can able to monitor and standardize this, and reusable share configuration across projects and environments that we can able to do. So Terraform modules are mainly building blocks of maintaining consistency across infrastructure deployment. Consistency across infrastructure deployment. So consistency means what? Throughout the
Standard.
same standard, yes, throughout the same space. It's not like one time it will work very aggressively, one time it will not work aggressively. No, this is software what I'm trying to. Okay, Terraform modules mainly exercise across infrastructure deployment. Now step by step module implementation, we'll go for step by step module implementation. Create module structure. First, we have to organize the files into folders with main.tf, where.tf, and output.tf for each file. Then define the module resources, specify AWS resources, specify AWS resources like S3 bucket with proper configuration. Next, call module in main project. Call module in main project. So reference modules with source attribute and required variables. So reference modules with source attribute and required variables. We can able to get it because just now we mentioned variables we create and we can able to call throughout our files. Next, call module in main project. Reference modules with some attribute and required variables. So definitely we need variables of each file. So reference modules with source attributes and required variables, as just now I told you. Next, deploy with Terraform commands. So what are the commands we have in Terraform? As I told you, run, initiate, plan, and apply to provision resources. To provision resources. I think you wrote already, right? Terraform initiate, Terraform
Yes,
plan,
yes.
Terraform apply. Okay. Following these steps of any module type, the pattern works for all cloud providers. Okay. Now here you can able to see the list of command Terraform plan. Now you can write and keep it for what reasons. So Terraform plan is for previewed proposed changes. Terraform show for display the current state. Terraform state list is for list all resources. Terraform state list all the name is says list all the resources. Terraform output mainly for view the exported values. And Terraform graph is like visualize your dependencies. It's also possible that all those things will do it, but you first write the comments in your notebook.
Okay, done, completed.
Okay, fine. So reviews regular ensure infrastructure match expectation. Audits deployed ensure weekly. Now, what are the benefits of module based infrastructure? First one, faster deployment. So deploy multiple environment with minimal changes. With minimal changes is possible through Terraform faster deployment. Next one, cleaner code. It's not like very complex code. Terraform code is a very easy code. Separate logic from configuration data. Next, reusability. So apply consistent patterns across environments. We can able to apply patterns across environments. And better review. You can able to track changes and resources impacts easily also. You can able to track the changes and impacts. You can able to review it. Track changes and resources impact easily. So here, as I told you, Terraform is a very lightweight tool which can be easily understood by anyone. Okay, that we'll see when we do the practical. We'll see. So track changes and resources impacts easily. We can able to see the impacts of the changes which is getting affected in easily and faster as well. This mouse is not working. Next, Terraform repository. Advanced module implementation option. Terraform repository, template repository. So we create organization wide module templates, standardized resource configuration with pre-approved security settings, base modules for all teams, version controlling templates, CI/CD integration. All these things will come under template repository. That means in the repository itself, we'll be able to configure all these things. What are all the teams it's going to be there, whether development team, testing team, and the production team is going to be there or not. And control templates also, version control. So multi-resource example, multi-resource means multiple resources restart at the same time. So combine VPC, EC2 and S3 modules for complete environment. Deploy entire application stacks with one command. So like one command, the application stack command is only one command which will execute all EC2, VPC and S3 bucket. So networking plus compute plus storage, cross module reference, dependency management. So all these things are there. So start with small focused modules before building some complex architectures. Okay, so we'll do a basic Terraform thing. Okay,
Okay.
I'll guide you. You just do it in your system.
Shall I share my screen?
Yes, you can share your entire screen and I'll tell you. You have installed anything before for Terraform? No?
No, this is first time.
Okay. Okay, go to Google and type Terraform. That one, click. You're able to see download a file. Download, install now. Come down. Scroll down, scroll down. Your system is Windows system, right? Go
Yes,
above.
Windows.
Select Windows is not the. Okay, this is part of the complete hands-on tutorials. That's what tutorials only. Okay, click that install. Download for Windows 386. This one binary file on this one. Copy that file. Extract that.
Shall I run this application?
No, 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 no. Wait. Don't run anything. Copy this. Copy this folder.
Yeah.
File.
Okay. Copied.
Copy this file alone. Terraform file alone. You
Okay.
copied, right? Okay. Go to C drive, program files, create a new folder called Terraform. You create a new folder called Terraform and paste that file inside that. Just copy this path, C program files, Terraform.
Mm.
You copy the path actually, program
Yes,
files, Terraform. Copy,
copied.
go there, edit variables. Go to edit variables as usual. Type it in your browser. Edit system variables. Edit the that one. Yes, open it. System variable. Yes, system variable below. Below that path is the collect path. Edit. Now paste the new one. Terraform. Okay. Enter. Click OK. Apply. Now go to Windows PowerShell. Open Windows PowerShell as an administrator. Simply type Terraform and enter. Okay, you're able to see it's there. Now check Terraform space version. Okay, Terraform version is installed. Now go to command prompt and check whether Terraform came. Terraform space hyphen version. Hyphen version. Okay, it's working. Both are working only. No issues. Now we'll create a folder. Okay, in your desktop
Okay.
called Terraform.
Terraform practical. Is it fine?
Then put a hyphen. Don't give space. See, if you're giving two names, don't give space. You'll get confused. Only Terraform is also fine. Simply Terraform. You created the folder?
Yes.
Yes, open that in the VS Code. Yesterday we opened like folder we created and open. Same thing. You open the VS Code and open this folder called Terraform. Yes. Close that build with agent right side and open your terminal. Okay. Now type Terraform space hyphen version. Okay, close your VS Code and open it. I think you open from the existing one, right?
Yes, correct.
Close VS Code and open it. Now again try. Okay, good. So Terraform okay. Now, okay. Now left side you are able to see extension. Yes, there you type Hassie Corporation HCL. First one, install that. Next, again type Hashy Corporation, Hashy Corp space Terraform. The second one. Yes, that one also install. Now we'll go and configure our AWS account. Okay. So for that,
Okay.
I think yesterday you created a root account user, correct? Na?
Yes.
Okay. In the root account user, we didn't delete that access key.
Yes. Correct.
Okay. You kept your access key in the notepad still.
Yes.
Okay, good. We'll go ahead with that only. Go to your terminal in the VS Code and type AWS space configure.
Shall I close everything?
This one you close. Yes. Terminal you type. Click left side. Yes. Terminal. Oh.
Southeast hyphen one.
Southeast hyphen one. JSON. Okay, we connected. Now create a new file. We are going to create the new file. So left side in the Terraform, we create a new file called main.tf. Main.tf. Yes, type it. Yes, now you type here provider. Yes, it's coming now. Terraform codes will come. Yes, AWS you type. Next, inside the curly braces, region is equal to
In
type
quotations.
region. No. Simply region. I will tell you if quotation is there. Region is equal to double quotes inside that AP hyphen southeast hyphen one. Now region is done. Now after this curly braces come down, enter. Yes, resource. Now you type resource. Yes, enter. Resource name is AWS underscore instance. Yes, that's our instance we are going to get. And name you give it as demo hyphen server. That's the server name. Demo hyphen server. Okay. Okay. Inside the curly braces, first one type AMI is equal to put double quote. Next come down. No. Inside the curly braces. Inside the curly braces, uh, type instance underscore type. You see it's coming. Instance underscore type is equal to double quotes t3 dot micro. Okay. Now go to your AWS account. We'll copy the AMI ID and come. Okay.
Okay.
So go to EC2 instance. Go to EC2 instance.
Okay.
Launch instance, click launch instance. In that Ubuntu is there, na? Select Ubuntu OS image. Come down, copy the AMI ID, paste that. Save this file. Control S, save it.
Yes.
Okay. Now in the terminal, we'll type the first command. Terminal, type Terraform space initiate. So no, initiate init init, no, in init. Enter. So let us wait. It will successfully getting created. Yes. Terraform has successfully created, initiated. Okay. So now what command we have given? We have given AWS Southeast region one instance ID. We have to create this. Correct, na? So
Yes.
let us first go for the next command. Terraform plan.
Plan. PLAN.
PLAN plan. Enter. Okay. Plan. See, plan is equal to one to add. You're able to see?
Yes.
One to add, zero to change. That is one to add. So now I told you plan means what? It will keep everything ready. Okay. It
Okay.
will show you all the options. Yes, everything is ready. Plan to add one means we are going to create one instance. Correct now.
Yes.
Okay. Now, so first, as I told you in the class itself, I want to launch EC2 means first I want what?
VPC.
First to go there in your account because we are giving command only for creating EC2 instance.
Yes.
Correct, na? But we
Correct.
didn't create a VPC. So click VPC left side, your VPCs left side, and select actions. Select actions. Create default VPC. That's it. Create. Over. Now we create a default VPC. You don't want to go for a manual configuration. Okay. Now you
Okay.
come back to Terraform. So plan is ready. Now source is also ready. Now we go for apply. So type Terraform space apply. To enter the value, it will asking yes. You type yes. That's it. You want to form the Terraform to perform all the actions. Yes. So it will creating. Let us wait. AWS demo server is getting created. Still creating. Creation complete successfully. Okay, now. Now go and check
Okay.
your EC2 instance. Let us see Terraform is there or not. Instance. Go to click instance left side. Yes.
Yes. Running.
Done.
Yes.
So your Terraform has created one instance in your account. Okay.
Okay.
So now this, so it is like we know that it is getting created, correct now because we have done the Terraform apply and everything. We
Yes.
understand it's created, but how public will know whether it is created or not. So we have to know that. For that we'll go for output file. We have to create output file, right? So
Right.
now go to the file and click left side, outputs.tf. Create a new file, outputs, small letter, everything small letter, outputs.tf. Okay. Now you type output, the name as public hyphen IP. Now inside the curly braces type value is equal to AWS underscore instance demo server. Select that. It's coming out on dot public underscore IP. Enter. Enter space. Okay, save it. Save it.
Done.
Okay. Now again go to terminal and type Terraform initiate. Don't want space. That space output space no need. INIT. In the file you have mentioned some values, no?
Yes.
Okay. Okay, leave it. It will not happen anything. Let us see. Now we have created an output file, so it should display the output file. So Terraform initiate is done already. Now apply directly. We don't want to go for plan because we already know everything is done. So Terraform apply last. That's it. Type Terraform apply. Yes, you type public IP address. You see public IP address. Yeah, you see public IP address came.
Yes.
Okay, we'll check it now. Cross check. 47.129.235 is the ID. Go and check that to the public ID. Click that.
EC2.
Click that. Select that EC2. So left side. Okay. What is the public ID? You see?
47, 129, 146.
Correct, na?
Yes. Correct.
Public ID is visible. Fine. So when we upload the codes to the GitHub, but we cannot show the AMI and instance, it has to be hidden first. Correct now? First, we will create some two files for that. We'll create the AMI ID and all. We should not show to the public. So we make this into a variables. We make that into variables. Okay. So go to your Terraform. Yes, this is done. Click instance left side and keep it. Now we will go for how to create variables.
Okay.
So go to your terminal. I mean, go to your VS Code and create a new file called variables.tf. Hey, here, left side file you create, man.
Sorry.
Yes, variables.tf. Yes, now you type variable. Uh, yes, in the name you give AMI underscore value. Okay. Inside the curly braces, you type description is equal to value for double quotes. You put double quotes value for my AMI ID. AMI ID. Okay. AMI ID you put it in caps letter.
Okay.
All AMID. AMI space ID. Okay. Okay. Value also you can put V caps. No issues. It's just a description we are writing. Okay. Now,
Okay.
again, next line, after this curly braces, type one more. After the curly braces, Enter one more enter. Type again variable. We are going to go for the instant type also. So variable in the curly braces type instance underscore type underscore value. Okay. Then we mention description is equal to same value for double quotes value for my instance type. Instance and type t in I and t caps you can give it so that it's just a description. Save it. Now we created the variables file. Correct now? We just now understand the definitions now. Main file, variables file, output files. Correct now? All these things
Yes.
have been created. Now see, but we have created the variable as AMI value. That means I can able to use this AMI value instead of wherever I get wherever I have this variable which we have created, I can use it. But we have to create some common Terraform variables file so that everyone can able to access throughout this program. So create one more file. You saved it now.
Yes, saved it.
Okay, create one more file called terraform.tfvars .tfvars. Yes, enter. Now you type here what are the two values we are giving. You go to your main file, main file, and copy that AMI value fully, AMI full value, fully you copy. Come to Terraform files, type. What is the definition we are given for in the variables actually for AMI underscore value, correct now?
Yes.
AMI underscore value, click that. Is equal to double quote, paste it. Yes. Okay. Next again enter. Same thing instant type also. We commonly define it here. Okay. It's like an index page.
Yes.
Type is equal to what is the file? T3.micro. T3.micro. Okay. Now we have
Done.
commonly referred here. Save it. We
Okay.
commonly referred here. Now since we have commonly referred here and again we are giving the main file the same value. Correct na? So
Correct.
that is wrong. So we have to go and change it in the main file. Now save it first. Save this one.
Done.
Go to
Saved
main.
it.
Okay. Now main file. We just remove that main file in the AMI place. Remove that value. AMI is equal to remove that value and type fully remove and double quote also remove. Type var dot. You see it's coming now. AMI the underscore value. Again same thing instant type also remove that instant type underscore value. That's it. Save it. Now again, what is the command we have to run?
Apply.
First initiate. Whenever you do some changes, Terraform initiate, Terraform apply. These are the two main commands. Plan is when first time if you want to change something, you can check it. Plan if you give
Okay.
also nothing, it's going to give. It's just going to check it. So Terraform initiate, Terraform apply. Done. Public IP address it came. Okay. Now we have done the normal part that is main output Terraform variables everything we have done. We have changed it, configured also. Now we'll check how to destroy this Terraform. Easy to instance. Go type Terraform, the terminal Terraform space destroy. Enter. Type yes.
Completed.
Destroyed.
Yes.
Okay, go to your EC2 instance and check whether it is destroyed.
Yes.
Mm,
Terminated.
okay, fine. Now go to our outputs file. What is the output we are given there?
Public IP.
Public IP, right? Okay. Now we can add one more. Just to close that curly braces space, you just delete that on the top. Delete that. Okay, come down. After the curly braces, again put output. Uh, and you type instance hyphen ID. So we previously got in output instance hyphen ID, not underscore hyphen ID. Okay, now inside the curly braces again type value is equal to AWS instance dot demo server. It's so incorrect. Dot id, and that's it. Save it. Yes. Now again you can Terraform initiate apply. It has to create new Terraform new instance and it has to show the output. That is instance ID also it should show. In the output we are given two things. So you want instance ID and public IP address.
Completed.
You see instant ID and public ID created.
Yes.
Okay, both are showing in the output. Okay, go and check it in your EC2.
Yes. Both are created.
Okay, one is terminated, one is running. Okay, na?
Yes.
Okay, now we'll create modules. We'll create modules. Go there. Now to create modules, what we'll do one thing. Go first to click Terraform. That name you click and okay, click and click folder. Second one. Folder name modules. Don't click enter, wait. Slash forward slash. Sorry, back EC2. Type EC2 underscore instance. Enter. Now you're able to see that. Now move all these four files which we created. Main.tf output to Terraform variables. All these things you put inside that instance. Move,
Okay, okay.
move. Uh, just drag and move to EC2, EC2, EC2. You select. There you put. Yes, same thing. Hmm. Okay, now click that modules. Let us see everything gone inside. Okay, everything gone inside now.
Yes,
Now for others, this is now inside a module. That is inside our module, we have the EC2 instance files. Correct?
correct.
Now others, the public wants to use or the other developer wants to copy your code. That's what called reusability. Okay. Now they want to copy yours means we need to give them access. Correct? For
Correct.
that we create one more main file. So select first Terraform and find new file called main.tf.
Inside modules only.
No, no,
Outside
not
modules.
inside links. Outside the modules. I told.
Outside the modules.
No, no, no. You select Terraform there. You select Terraform. Don't click that form. First select no the above one. The above one. Now you select folder, file, main.tf.
It is
Main.
creating file inside
No
modules.
issue. You type first. It'll come out. You type first.
Yeah.
You type first.
Yeah.
Main.tf. You type.
Okay.
Enter.
It is already there with the same name.
No, no, man. You are not selecting the right file. Okay, do one thing. Click the Terraform lock is there na below.
Yes.
Now you click new file. Type main.tf. Enter. You see it's outside. You see this
Yes.
Terraform dot state file is there na? We were talking about state file below Terraform dot t state. You see this is a state file which is automatically created. It will have the first version copy everything it will have. Okay, that's why whenever you do a change, only that change alone will apply. In case if you delete this state file na, what will
Yeah.
happen you when you type to Terraform initiate again, automatically again it will start from the beginning. Okay, now as of now we don't want
Okay.
to do that. We'll come for outside thing. Select the new one, new main.tf. Go to your old main.tf, the inside the folder you have something, copy that fully. Come to main this.tf, paste it. Okay, first line provider is correct. Now AWS instant demo server, the demo server you remove it. Now this is the common configuration which we are going to give it for others. Remove that name also. That double code also you remove. Okay. Next AMI. Okay. Below first one you put first one. Enter. Type there. Source. Source. What is that you have mentioned? Resource. Resource you just remove that. First one the name is resources. Then resource instead of that you put modules. Module. Okay. Source. Now source you put double quotes. First one dot slash. You see it's coming now. Easy to instance. Select that. That's it. Next AMI underscore value. First one AMI underscore value is equal to. Now you go copy from the. No, two values came. It seems. Remove that. You see AMI underscore value. Remove that AMI. Value is equal to double quotes. Go for the Terraform dot tf vars. TF vars, you have the AMI ID. Copy that and come. Yes, next one, instant type underscore value, instant type underscore value. uh, what the value is, see, that is again changed. You remove that, remove again instant type variable. Okay, that variable name is what, instant type is what, t3 micro. Delete that fully. uh, Delete that. Double quotes t3, double quotes t3 dot micro. That's it, save it. Okay, again type terraform initiate and apply. I think terraform, wait, don't put apply. We just type terraform apply, sorry, terraform destroy. Hmm. We want to destroy the previous one which was created by inside module. Okay,
Okay.
then we will create by outside module.
Completed.
Go check your instance. Is it deleted?
Yes. Terminated.
Okay, now again come back. Now we will have one more output file in the output method, that is main output. The main is selected na, the outside main. And there again you
Yes.
click one more file and type outputs dot output dot tf. Outputs dot tf. Mm. Now same thing, from that outputs you copy, or you just type output, just type output, uh, public underscore ip, public underscore ip, first one, second one. Inside that you type value is equal to module, dot aws instance. You see it's coming, dot public ip, you see below one, second one. Next again one more output file will give, select outside, output, uh, instance underscore id. Next one, value is equal to module dot, same thing, module dot aws instance dot instance id. You see it's coming. Save it. Yes, so now we are going to use the output file. So now type, go and type terraform initiate apply.
Completed.
Okay, fine. Now go and check whether you have created an instance.
One is created.
Yes, so one is created from the outside file itself. So you are able to see that when compared to the other commands, Terraform commands are easy. Only the code we have to understand correctly where we create variable, where we create var tf.
Okay.
Fine. So you know how to destroy it, right?
Yes, Terraform destroy.
That's it.
Completed.
No, okay. Fine.
Yeah, terminated.
No, okay. Now we'll go for one more thing, that is S3 bucket. Okay.
Okay.
Now create a new folder by clicking this module is there na?
Yes.
Click that module, create new folder called S3 underscore bucket.
It will create inside module, right?
Yes, S3 underscore bucket. Hmm. Okay. Now click that S3 underscore bucket
Okay.
and create a new file called main.tf. Main.tf. Yes, it is in the S3 bucket. Okay, now as usual, provider, main file always should have provider, AWS. Yes, come down in the curly braces, region
A piece of this type one.
AP South, AP hyphen Southeast hyphen 1. Okay, now below, come down, curly braces, below resources. Put double quotes for the AP Southeast and all. That's why it's not. Uh, resource name is AWS. First one AWS underscore S3 hyphen bucket. No, hyphen la, underscore bucket. This is the name. You see, it's automatically coming. Name, our bucket name is sample bucket. Sample underscore bucket. You have created any sample bucket inside your account?
No.
Okay. Now to type bucket. Bucket is equal to double quote. Nothing. Nothing we don't enter. Come down. Again next one, enter. After bucket you enter. There enter. Tax. Tax is equal to curly braces. Curly braces. No. Curly braces. Enter. There you type name is equal to double quote my hyphen bucket. My hyphen bucket. Okay. My you can put M caps. Next one. Environment. Enter environment. No. As a env it's my env is equal to double quotes div d caps div, that is development environment hyphen environment e caps. Here you type fully environment. That's it. Save it. Okay. Now again click S3 bucket folder and select create one more file called variables dot tf. Hmm. Type it as variable bucket name, bucket hyphen name. Under description you said variable description is equal to value for the bucket name, value for the bucket name. Save it. Again now create one more file called outputs.tf. Bucket s3 bucket outputs.tf. There you put output double quotes inside bucket hyphen name. Inside that you put value is equal to AWS underscore S3 bucket. I see it's coming now. Select that. Dot bucket. Dot bucket. Save it. Now we have created everything here. Okay, that is inside the modules we created. But outside file we didn't put this about this output. So go to our outside output file. Main file. First go to output main that one. Yes. Now again click one more module name. Enter module AWS underscore S3 bucket. You see it's coming. Next inside that source is equal to dot slash modules. Now okay, I think it is going inside this one source file. It's not inside this module it seems. Hmm, it is coming under EC2 instance. Okay, we'll do one thing. You type module slash S3 bucket underscore bucket. No, underscore S3 underscore bucket. Right. Do one thing. Just click that. Click the Terraform. Top first Terraform folder and click it. Create new folder. No. Click above new folder called S3 underscore bucket. Uh, Now you move all these S3 main file, everything there, all these three to here. Hmm. Now delete that S3. That one you delete. Now move this S3 bucket to modules. Drag it to module alone. There you put. Okay. Now you click modules. Like this only the structure should come. Okay, na?
Okay.
Now anyway we'll check it. Just click that source. Edit that source. Edit that source. No. In the command. In the command. Then here the file you are typing now, na, currently source S3 bucket S3 bucket. There. There you delete that. Let me check. Delete that line. Okay, wait. Dot slash. Uh, S3 bucket is coming now. You see correctly it's coming. The fourth line. Wrong. That
This
one.
one.
Fourth one, select. Correct. Okay, now again next one. Bucket name. Enter. No, curly. Inside the curly braces. Uh,
Okay.
bucket name. Bucket underscore hyphen name is equal to double quote sample hyphen bucket. Hmm. Okay. For EC2 instance, save it. Save this file.
Okay.
So this is a main file. It is outside file, correct? Na? So outside file main is done. Now we go for outside output file. We have to know output also, na, whether
Yes.
S3 bucket is created or not. So click outputs. There again you type output S3 underscore bucket. Bucket. Again type value is equal to module dot. It will come automatically S3 bucket. You see module dot S3 bucket dot bucket. Name it's coming. You see. That's it. Save it.
Okay.
Now everything done. Now if you want to see how the files are organized, you can put it in the terminal saved, na? You can
Saved.
just
Yeah.
type ls modules. You just type modules. Enter. You see neatly EC2 is separate module and S3 bucket is separate module.
Okay.
Simply type ls. You see all the files outside. Okay.
Okay.
Okay, now type Terraform initiate and Terraform apply. We are going to create now two resources to at the same time. What are the resources? EC2 and S3 bucket. Are you
Okay.
getting
Getting.
all the two, both the resources we are going to do same time. Next, Terraform apply. You're able to see bucket name is created, instant ID created, public ID. All the three are created.
Yes. Created.
Okay, go and check there in EC2 and also open S3 bucket also.
It is running.
Okay, open S3 bucket in new page, one more tab, new tab.
Yes.
Yes,
Yeah.
Terraform created, Terraform bucket created, open
Yeah.
Terraform. That's the bucket created, okay?
Okay.
Okay. Now come to terminal. Okay, now to the other commands, we can just see Terraform plan. You can just mention Terraform plan. It's not necessary now. Simply put Terraform space plan. It'll show you. You see, two resources are added. You see, after complete apply complete resource two added. Two resources added.
Yes.
Okay. Yes, no changes because we didn't do anything. Our configuration is over. Correct, na? So
Okay.
Terraform plan we usually put after Terraform initiate. Okay.
Okay.
Fine. Next to Terraform space show. The things which we learned in the slide, na? Terraform show, Terraform plan, Terraform graph. We'll see all those things. And state list also. So you're able to see the variable is created, instance ID, public ID, everything. Whatever we showed, it is there. Versioning also, you see, enabled is false. What are all the metadata it is having, it is showing. Scroll above. Hmm. You see, all these things related to here. Easy to instance everything, bucket everything, it is showing.
Okay.
All the details it will show. All your metadata information you will get it by Terraform show. Okay, next one, Terraform graph. Come down. Terraform graph. Yes.
Got it.
Okay. Terraform show also to show what are things the graph is saying. It will give you all the details, main details on. Next is Terraform state space list.
Terraform space
List
states.
list.
Got it.
No, okay. Now we didn't do anything, so let us see. Let us go to S3 bucket. Change the bucket name. No. There in the command. S3 bucket main file is there, na? Ah, there you see my bucket name. My bucket is there, na? Just change it to my bucket to bucket. Hmm. Now save it and just put Terraform apply.
Not INIT.
No. Terraform apply alone you type.
Completed.
Yes. So
One
you see
change.
one change, correct? Na?
Yes.
Only one change you have done. That change alone it came. Okay. So the last thing is like as I told you, the Terraform dot tf dot state. In case if you delete sometimes, okay,
Okay.
it will what it will do since the state file is there. Whenever you do see Terraform apply we done correct now. Usually
Correct.
apply done what will happen? It will restart from the beginning, correct now. But
Correct.
now what has done? It has only changed. Okay, it has only
Change.
changed. So if you delete that file, what will happen? Again, everything will get recreated. Okay. This is
Okay.
just for your knowing purpose. You can see terraform.state tf state is there. One more terraform.tf state dot backup is there. It will also keep a backup also.
Okay.
Okay. So now we are coming to the end of this section. You can just type terraform what to destroy everything.
Destroy.
That's it. Okay, give it.
Completed.
Hmm. Okay, two resources are destroyed. Go and check there. Click buckets. Hmm. Video string yesterday you didn't delete it. Delete it. Copy that and paste it. That's it. Video streaming and the delete. Copy that and paste it. That's it. So deleted. So easy to instance again. You check.
Yeah, terminated all.
Okay. Go to VPC and delete that VPC. Subnets you delete first. Then it. Next to your VPC, you delete that VPC.
Done.
Okay, fine. So today's thing is done. Next week we'll do some two more labs and we'll be finishing Terraform. Okay.
Okay, here a DHCP option sets are there. One is there.
Just click that and delete that.
Yeah, completed.
Okay, fine. So I'll send you the notes. You can just to follow it. Okay.
Okay.
Okay, Kumar. We'll see you next week.
Okay, thank you. Bye.
Thank you.